morning. This is Dr. S. Kumar, lecturer in mathematics, Government Degree College, Puttur, Tirupati district. Today I am going to explain sequences and their limits. It belongs to the unit of real numbers and real sequences. It is for the second year student semester 4. Okay, in detail we are going to see the next slide. First of all, we know the definition of sequence. Definition is a function, yes, Z plus to R is called a sequence of real numbers or a sequence from the definition of the sequence. We observe that a sequence S is a specified rule which associates to each n belongs to Z plus. Exactly, one S of n or Sn belongs to R. A sequence S is the set. The set is defined like this: n comma Sn such that n belongs to Z plus. This is called the sequence. Here we see some notations of sequence. How you write the sequence? Okay, since the domain of each sequence in Z plus, a sequence is determined completely if Sn is known for each n belongs to n. We should denote a sequence S Z plus to R or S by S1, S2, S3 and so on Sn. Okay, or S of n, comma S of 2, comma S of 3 and so on, S of n and so on. Or and also we do not like this. Notations are Sn from n is equal to 1 to infinity. And also here also there is another two notations here. S of n from n is equal to 1 to infinity. Sequence Sn. This is okay in terms of in between flower brackets. Okay, this is Sn. Or Sn is another form. Okay, now this is one. This is the notations of sequence. The images S of n or Sn of a positive integer n is called the nth term of the sequence S. Therefore, for the sequence Sn, S1, S2, S3 and so on, this is the sequence example respectively. Here S1 is called first term, S2 is called second term, S3 is called third term and so on. Okay. Now we are going to defining sequences in different ways. For example, here defining a sequence by one or more formulas so that nth term of each n belongs to n can be found as some example 1 and example 2. Yet the sequence Sn defined as Sn is equal to 1 by root n. We replace here n is natural numbers, n is equal to 1 means 1, 1 by root 2. Suppose let we take n is equal to 3, 1 by root 3, let we take n is equal to 4, 1 by root 4 and so on, 1 by root n. So that in the 1 is S1, 1 by root 2 is the S2 and so on, 1 by root 3 S3 and so on like that. This is first term, second term, third term, fourth term and so on like that. So for example, Sn is equal to 1 by n if n is even and minus 1 by n is if n is odd. We define when n is even and n is odd. Like that we write the sequence here. Here sequence Sn is equal to minus 1. Minus 1 means if n is odd means 1 minus 1 by n. Therefore 1 by n we replace n is equal to 1, that is equal to minus 1. Okay, 1 by 2 if n is even, that is called 1 by n. Okay, 1 by 2 comma minus 1 by 3, 1 by 4 and so on. Minus 1 is the first term, this is second term, third term, fourth term, that is called S1, S2, S3, S4 and so on like this. This is the sequence methods. And also we defining sequence by a recursion formula or inductive formula, that is by formula which express nth term of in terms of n minus 1th term. For example, here we take the sequence Sn is equal to 2n of even natural numbers can be defined as Sn is equal to 2 and Sn plus 1 is equal to Sn plus 2. In example 2, S1 is equal to root 2, Sn plus 1 is equal to root of 2 plus S1. Suppose this one given, we write down the next one sequences. S2 is equal to root of 2 plus S1. That means here n is equal to put it 1. Okay. Therefore, S2 is equal to like this. Here S1 is equal to root 2. Therefore, root of 2 plus root 2. In the same way, S3 is equal to 2 plus S2. 2 plus in the S2 plus root 2 plus root 2. Like that, root of 2 plus root of 2 plus root of 2 and so on. Like this is the one type of sequence recursion. And in the next one, example 3, S1 is equal to 1 and S2 is equal to 1 and Sn plus 2 is equal to Sn plus 1 plus S1 for all n greater than 1. From the above formula, S3 is equal to S2 plus S1. Okay, that is equal to 1 plus 1 is equal to 2. S4 is equal to S3 plus S2, 2 plus 1 that is equal to 3 and so on. Therefore, the sequence will become S1 is equal to 1 comma 1 comma 2 comma 3 comma 5 comma 8 comma 13 comma 21. So this numbers is called Fibonacci sequences. Okay, like that the example 1, in example 2, in example 3 we define sequence by recursion formula. Okay, this is called the Fibonacci sequence 1 1 2 3 5 8 13 21. Like that we define sequences, and also we define some types of sequences. Constant sequence, a sequence Sn defined by Sn is equal to C of C, that C belongs to our real numbers, is called the constant sequence. The constant sequence Sn is equal to C comma C comma C and so on, like that. For example, the constant sequence 1, suppose 1 1 1 and so on. The constant sequence 0 0 comma 0 comma 0 and so on. The constant sequence 5 is equal to 5 comma 5 comma 5 and so on. Like that, the constant sequence will be there. And also we know the about some operations of sequence. Here I am giving here 4 operations here. In the first operation, Sn, sequence Sn and sequence Tn are sequences. Then their sum sequence is defined by Sn plus Tn, sequence Sn plus Tn, and the product of sequence is defined by Sn into Tn. Okay, this is the first operation. Sequence Sn plus sequence Tn is equal to Sn plus Tn in the same sequence. Sequence Sn into sequence Tn is equal to Sn into Tn in the same sequence. Like that, the first operation will be there. If Sn is sequence and C belongs to R, then the sequence Sn is equal to, we write constant Sn. Okay, and minus Sn, minus 1 into Sn is defined as minus Sn. It is called the negative of the sequence Sn. Okay, this is the sequence Sn's negative sequence is minus Sn. Like that, the second operation will be there. If Sn is a sequence and Sn not equal to 0 for all n belongs to Z plus, then the sequence 1 by Sn is called the reciprocal of given sequence. Okay, and also the fourth point, if Sn is a sequence and the reciprocal of sequence of Tn exists, then Sn into 1 by Tn is equal to sequence Sn by Tn is called quotient space. It's called quotient space. In the operations, in first operation, second, third, fourth operations, the first one is some additions and multiplications here. In the second sequence is negative sequence is there. In third sequence is reciprocal sequence, and the fourth point is quotient space. Like that, these are the operations of sequences. Now we define some nodes of the sequences here. This is the some important theme of the sequences. If Sn is sequence and n are the sequence of positivities such that n1 less than n2 less than n3 and so on. Therefore, the sequence SNR is called subsequence of S1. Okay, this is the definitions of subsequences. In the note 1, since sequence NR is a sequence of positive integers such that n1 less than n2 less than n3 and so on NR is strictly increasing sequence. Whenever the sequence is increasing, then it is the subsequences of sequence. In the note 2, if un is subsequences of Sn, then there is a strictly increasing sequence Rn, strictly increasing sequences of Rn of positive integers such that un is equal to Srn for all n belongs to Z plus. In the node 3, un is the subsequences of Sn and Vn is subsequences of un. Then Vn is subsequences of Sn. Okay, these are the definitions of subsequences and also examples. Okay, now we are going to see some illustrations, examples of sequences. Okay, 1 2 3 4 5 6 7 examples I am giving. It's very useful to you. Now let's to see first example, first illustration. Let 1 comma 0 comma 1 comma 0 comma 1 comma 0 be the sequence such that here s1 is equal to 1, s2 is equal to 2, s3 is equal to 1, s4 is equal to 0, and so on. For n is equal to 1 3 5 and so on, the sequences are positive integers such that all are the increasing sequences. Therefore 1 1 1 is a subsequences. Similarly, n1 is 2, n2 is 4, n3 is 6, like that. Then here 0 comma 0 comma 0 is the another sequences. Okay, now in the second point, sequences 2n minus 1 and 2n are subsequent sequences of sequence n. In 3, the sequences of primes 2 3 5 7 11 is the subsequences of 1 2 3 for natural numbers. Number 4, the sequences of S2n and the sequence S2n minus subsequences of the sequence Sn. That is S2, S4, S6, S1, S3, S5 are the subsequences of S1, S2, S3, S4 and so on. Here the even number of sequences, odd number of sequences are subsequences of natural numbers. 7 square, 3 square, 15 square, 11 square, 19 square is not a subsequences of 1 square, 2 square, 3 square, 4 square. Why? Because here n1 is 7, n2 is 3, n3 is 15, n4 is 11, n5 is 19. Here we see here the n1, n2, n3, n4, n5 is strictly, it's not increasing sequence 7, 3, 15. Okay, here 7 decreasing and then increasing, decreasing, like that. So whenever subsequent condition is strictly increasing sequence is called a subsequence. Number 6, 1, 1 by 3, 1 by 5 and so on, 1 by 2 minus 1, 1 by 2 factorial, 1 by 4 factorial, 1 by 6 factorial and so on, 1 by 2n factorial are two subsequences of Sn is equal to 1 by n. Okay, next 7, 1 by 2, 1 by 1, 1 by 4, 1 by 3, 1 by 6 and 1 by 1, 0, 1 by 3, 1 by 4, 0. Okay, these two are not subsequences of Sn is equal to 1 by n. Okay, this is the completely up and down sequence. First of all, decreasing and increasing, increasing, decreasing, like that. Therefore, it is not a subsequence. In the sixth point, always these are the increasing sequences, Therefore, these two sequences are subsequences of Sn is equal to 1 by n. Like that, we are giving some examples here. Note down, it's very useful to you. Okay, this is the information about the sequences and their types of sequences and model of sequences, some examples of sequences. Okay, thank you very much. Now we are going to see some some materials. I am providing some materials to the my link here, providing reading material. You see reading material here. This reading material is very important to you. Okay, it's in MS Word format. You see here, semester 4, paper 4, unit 1 and topic 3. Okay, topic 3, real numbers, real sequences. These are very useful to you. Definition and notations are there, and also some methods of defining sequence, and also some types of sequences, operations of sequence, definitions of subsequence, and also some illustrations also given here. The reference book also given. This is very useful to you. And also I am providing some reading material in PDF format also. Notes of the sequences here, you see, this is the notes of the sequences and its applications. Okay, see here, same, this one very useful to you. Okay, this link is provided in my YouTube. And also I am providing some assessment questions. Okay, in assessment questions there are three types. One is multiple choice questions, true or false, match the following. First of all, we see the multiple choice questions. Okay, see, first the negative of the sequence SN. So what will be the negative of the sequence? Here see, either A or B or C or D, which is correct. Minus SN is the correct value. So for here B is the correct answer. In the same way, true or false questions also I am giving. Okay, for example, I am taking here Sn plus Tn is not equal to Sn plus Tn. Whether it is correct or wrong? It's correct, but you say is equal to, but it is not equal to is given. Therefore, it's false, completely false. In the way, I am giving five true or false questions, and also I am giving match the following questions also. For example, Fibonacci sequence. Which is the Fibonacci sequence? Fibonacci sequence is Sn is equal to 1, 1, 2, 3, 5, 8, 13, 21. This is the Fibonacci sequence, This one is 2. Okay. For example, C answer is 2. Like that, this is the matching of the questions. Like that, I am giving very useful information to you. Therefore, it will be useful for second year students, real numbers and real sequences. Okay, thank you very much.